Hello students, now in this module we are going to learn about the mechanism for Markovnikov's rule, that is precisely speaking the mechanism for hydrohalogenation reaction. तो चलो जल्दी से एक काम करते हैं. We'll first discuss out what is the basic reaction of hydrohalogenation. We have already seen that you have a molecule of alkene, ethene molecule ले लिया आपने. इसमें you are adding HBr. What will happen? H will get added to one carbon atom, Br will get added to another carbon atom. So एक alkene that is ethene से आपने क्या बना दिया? You have prepared a alkyl halide. In this case, it is ethyl bromide. Also, over here we have said that अगर आपके पास एक unsymmetrical alkene होता तो आपके पास दो possibilities होती. That is, you will get one product as a major product, another product as a minor product. And वो किस लिए? Because Br can attack either the first carbon or it can attack the second carbon. And then we need to determine which one is major, which one is minor. अच्छा वो कैसे करते हैं? So that would be determined using a rule called as Markovnikov's rule. So right now we are going to discuss about what exactly is the Markovnikov rule. It says that in an unsymmetrical alkene, the negative part of the addendum. Okay, now first thing over here, what exactly is addendum? Addendum is basically your reagent. जैसे HBr है यहाँ पे. So HBr is a person that you are adding to the alkene. So it is an addendum. Okay, so an unsymmetrical reagent or an unsymmetrical alkene is treated with an addendum, which is an unsymmetrical reagent. Then the negative part goes to the carbon, which contains less number of hydrogen atoms. Okay, this was Markovnikov rule. What we are going to study right now, we are going to precisely study the mechanism of Markovnikov rule. Let's see. Step one, a very important step, and बहुत simple भी है. Step one is what? Step one is the formation of an electrophile. Now, we all know what is an electrophile. क्या होता है electrophile? Electrophile is a species which is an electron-loving species. That means if a species loves electron, or rather he gains electron, the species must be positively charged. तो पहला step is आपको एक positively charged species बनानी है which will act like an electrophile. अच्छा ये कैसे होगा? देखो, over here in the case you have HBr, it will dissociate to give you H positive and Br negative. H positive is an electron deficient species. Therefore, what he would do is he would act like an electrophile and he would attack the electron rich double bond. Acha, why I'm saying electron rich double bond? Because double bonds में हमेशा क्या होता है? Double bonds में हमेशा एक pi bond होता है और एक sigma bond होता है. And pi bonds can be broken easily, so they are a very good source of electrons. अब देखते हैं what will happen in the second step. In step 2, the attack of an electrophile will take place. Acha, obviously, where will the electrophile attack? The electrophile will attack on the double bonds. Double bonds में भी कौन से bond के ऊपर? Pi bond के ऊपर. So होगा क्या देखो? H positive, he will go for the attack. Let's suppose if he attacks the first carbon atom, okay? Out of the two doubly bonded carbon atoms, the electron deficient species attacks on the first carbon atom. Then what would happen? You would get a species that would be CH3, CH, double bond टूट जाएगा, giving you CH3, and the carbon which was not attacked by hydrogen positive or a hydride ion, sorry, a hydronium ion. What will happen now? That carbon will gain a positive charge. Similarly, H अगर second carbon के ऊपर attack करता है, then you would get the second possibility, that is CH3, CH2, CH2 with a positive charge. अच्छा यहाँ पे बच्चों प्लीज याद रखना, अगर H पॉजिटिव फर्स्ट कार्बन के ऊपर अटैक करता है तो पॉजिटिव चार्ज सेकंड कार्बन के ऊपर चला जाएगा. अगर H पॉजिटिव सेकंड कार्बन के ऊपर अटैक करता है तो पॉजिटिव चार्ज फर्स्ट कार्बन के ऊपर चला जाएगा. दिस इज अ शॉर्टकट दैट यू विल रिमेंबर. Okay, so this will be the case. Acha, now just notice, in the first case, the carbon which is getting the positive charge, is it a secondary carbon? Absolutely yes. Hey, and in the second case, it's a primary carbon. अच्छा हमें तो पता ही है ना कि secondary carbon and primary carbon, which carbocation is more stable? Then we already know tertiary carbon is more stable than secondary, is more stable than primary. And अगर ये चीज follow की तो secondary carbocation will be more stable, primary carbocation is less stable. And therefore, what you will say that the first compound, which is a secondary carbocation, is predominantly formed. वो बहुत ज्यादा amounts में बनेगा. ओके, क्यों? क्योंकि वो एक स्टेबल कार्बोकेटायन दे रहा है। तो अगर वो एक स्टेबल स्पीशीज बन रहा है तो डेफिनेटली इट विल बी फॉर्म्ड इन लार्जर कॉन्सेंट्रेशंस, करेक्ट? एंड देयरफॉर व्हाट यू वुड से, द फर्स्ट कंपाउंड और द फर्स्ट carbocation which is a secondary carbocation is a major product, whereas the primary carbocation is a minor product. Okay, अब आगे देखते हैं. The moment you get your major product, now what is the third step? The third step is simple attack of the anion. होगा क्या? आपके पास एक सेकेंडरी कार्बोकेटायन था. अच्छा, व्हाई वी हैव टेकन ओनली सेकेंडरी? बिकॉज हमने बोला था प्राइमरी वैसे ही कम बनेगा, माइनर प्रोडक्ट होगा, तो मेजर प्रोडक्ट के साथ रिएक्शन करके देखते हैं. सो मेजर प्रोडक्ट वाज योर कार्बोकेटायन. व्हिच कार्बोकेटायन? द सेकेंडरी कार्बोकेटायन. कार्बोकेटायन के ऊपर Br नेगेटिव एनायन का अटैक हो जाएगा, गिविंग यू व्हाट? गिविंग यू द फाइनल प्रोडक्ट व्हिच इज CH3 CH BrCH3, and this compound would be referred as 2bromopropane. Once again, एक बार जस्ट चेक करते हैं कि हमने जो प्रोडक्ट फॉर्म किया है क्या वही प्रोडक्ट बनना चाहिए था या वो नहीं बनना चाहिए था. सो लेट्स चेक ओवर हियर. आपने सबसे पहले लिया था प्रोपेन, सॉरी प्रोपीन. सो यू हैड CH3 CH double bond CH2. To this you added HBr. HBr would be H positive and Br negative. Okay, then you said that yes, because the alkene is an unsymmetrical alkene, the reagent is an unsymmetrical reagent, the negative part of the reagent should go to which carbon atom? Should go to the carbon atom containing less number of hydrogens. Matlab, sir, Br should go to the second carbon and H must go to the first carbon. अच्छा, अगर ये फॉलो करते हो तो what is the final product? चलो देख लेते हैं. तो फाइनल प्रोडक्ट क्या बनेगा आपके पास? आपके पास बन जाएगा CH3 CH Br single bond CH3. And check karo, is this product, that is 2bromopropane, and this product what you have formed in the mechanism are the same? And absolutely yes, they are same. अच्छा, क्यों सेम हुए? सर बिकॉज इस प्रोडक्ट फॉर्मेशन में एक इंटरमीडिएट आया, which intermediate was called as a carbocation intermediate. Now very important points that you need to remember over here. Check karo kya kya important points hai. The very first point, which was the intermediate form. The intermediate formed is a carbocation intermediate. Matlab, over here whenever you are adding Br or whenever you are adding the negative part of the reagent, okay, it might be Br, it might be Cl, it might be iodine, वो कुछ भी हो सकता है. तो जब कभी भी आप एक नेगेटिव पार्ट ऐड करना चाहते हो across the double bond, you will always add the negative part on the most stable carbocation, the most stable carbocation. आप ये नहीं देखोगे कि नंबर ऑफ हाइड्रोजन्स कम है या ज्यादा है. That's fine. Number of hydrogens is less and more. It's absolutely fine. But then what you need to remember is कि पहले डबल बॉन्ड तोड़ो, फिर ये देखो कि कौन सा कार्बोकेटायन सबसे ज्यादा स्टेबल बनेगा, and then you would attach the negative part on that carbon atom. Okay. The second and the most crucial point that you need to remember over here is, sir, because you are forming a carbocation and जब carbocation बनता है, this carbocation can perform a rearrangement reaction if possible. Okay, this can undergo a rearrangement reaction. इसका मीनिंग क्या है? जल्दी से एक एग्जांपल लेते हैं एंड चेक करते हैं. ओके, लेट्स सपोज आपके पास एक मॉलिक्यूल है ऑफ CH3 CH डबल बॉन्ड C CH3 CH3. okay, so what is the first step my dear students? चेक करना, हर स्टेप के ऊपर बहुत ध्यान से नजर रखना. What is the first step? सब पहला स्टेप ये है कि डबल बॉन्ड ब्रेक करो. आफ्टर ब्रेकिंग द डबल बॉन्ड, आप दोनों कार्बन्स को, जिन दो कार्बन्स के बीच में डबल बॉन्ड है, both the carbons you associate with a positive charge. So देखते हैं. So सबसे पहले मैंने डबल बॉन्ड ब्रेक किया, मैंने कंपाउंड वैसे ही लिख दिया CH3 CH डबल बॉन्ड की जगह सिंगल बॉन्ड बना दिया, यहाँ पे C CH3 CH3. ओके, अब क्या करना है सर? जहां पे डबल बॉन्ड था ना, उन दो कार्बन्स को आप पॉजिटिव चार्ज के साथ एसोसिएट कर दो. मतलब either the positive charge can come on this carbon or the positive charge can come on the other carbon. Let me mark it with different color. या फिर इस कार्बन पे आ सकता है. Okay, अब check करो. So the blue carbocation, what you have written, is this carbon connected directly to 3 other carbon atoms? Then yes. Therefore, ये जो blue वाला carbon atom है या ये जो blue वाला carbocation है, this carbocation is a tertiary carbocation, whereas ये वाला जो carbon है, which is the red carbocation, so it is connected to only 2 carbons directly, and therefore this becomes a secondary carbocation. So right now, tell me who would be more stable? Then definitely tertiary would be more stable. तो आपका जो negative part है, that is Br minus, वो Br minus कौन से carbon पे जाएगा? The most stable carbocation. मतलब what you are going to get is you are going to get a compound CH3. देखो मैं वापस वही लिख रहा हूँ, CH3 CH CH3 over here and one more CH3, and then you said sir this carbon is a tertiary carbon, so it would be more stable carbocation. तो उसके ऊपर क्या आ जाएगा? उसके ऊपर आ जाएगा Br and दूसरे वाले कार्बन के ऊपर आ जाएगा H. तो क्या आपने H and Br across the double bond add किया? जी हाँ, बिल्कुल add किया. But then how did you add? If it was a symmetrical alkene तो कोई दिक्कत नहीं थी, कैसे भी add कर दो, doesn't make any difference. But if it is an unsymmetrical alkene, you found out that which is the most stable carbocation. आपने double bond तोड़ा, आपने ये सोचा कि इस कार्बन के ऊपर भी डबल बॉन्ड पॉजिटिव चार्ज है, दूसरे वाले कार्बन के ऊपर भी पॉजिटिव चार्ज देख के देखते हैं इन दोनों में से which carbocation is more stable, आपने वो डिटरमाइन किया, and then to that you added Br as a negative reagent or a negative group. So I hope the mechanism of Markovnikov's rule is clear in your minds now. एक चीज का ध्यान जरूर रखना कि अगर आप एक स्टेबल कार्बोकेटायन बना सकते हो तो वो स्टेबल कार्बोकेटायन बनाएंगे कैसे? रीअरेंज करके. Fine. So with this we'll end the module over here. Hope you have understood the mechanism for Markovnikov's rule pretty clearly. We'll meet in the next module with anti-Markovnikov's rule ka mechanism. Till then, thank you students and happy learning.